My name is Peter Geoghegan. I work for Heroku on our cloud database platform, Heroku Postgres, and I'm going to be talking about UPSERT use cases. So I was thinking about this whole problem for a long time. It was a relatively contentious patch. In aggregate, working for it on and off about 2 years. So it's a long time coming, and I'm very happy with what we came up with, and I'm very pleased to show you how I think it's unique and how I think it is a differentiator for Postgres. First of all, what is UPSERT? It's this idea of being able to either insert or update a row on the basis of something like an existing version of the row already being there. It's about being able to do this in a simple way with the minimum of fuss. I'm very particular about what this means in detail. So it's about us worrying about the concurrency, the avoidance of race conditions, and so on, so you don't have to. It might be that other systems failed to meet my definition of UPSERT. The details vary. So I'm going to tell you what I think it is. Now, I'm equivocating a little bit when I say you don't have to worry about concurrency, because, that's never quite true, but certainly no more than you would have to worry about it in context of having an update, we'll say, in read committed. So I invented this jargon to try and formalize what I'm talking about, the fundamental UPSERT property, because I'm sort of into inventing jargon. And what I mean by that is that you don't get what I called unprincipled deadlocks. Deadlocks where there's no user-visible mutual dependency, where, as far as you as an end user are concerned, there's no mutual dependency of locks because you don't see the locks because they're implementation level locks. It wouldn't have been acceptable in general if we were to say to you, when you get deadlocks, oh, just don't do so much upserting. In every other context, you can simply, reorder things in your transaction so that just doesn't happen. So obviously that should continue to be something that you can always do. Wouldn't have done to have these unprincipled deadlocks, and some systems suffered from these issues for a long time. Also, no spurious unique violations. The feature is defined in terms of avoiding would-be unique violations and getting an update instead. It wouldn't have done if you just sort of sometimes didn't have that happen and just got a unique violation anyway. That's the entire definition of what I was doing was to have that not happen. So it's really all about these sort of guarantees about what must happen. So it's all sort of driven by an insert. I'm going to show you the syntax in the next slide. This is probably most compelling in the context of OLTP, web apps, and so on. So hopefully my slightly more formal definition of UPSERT will gain currency, and it'll generally be formally understood to mean that. I should note that MySQL's insert on duplicate update thing it doesn't meet this standard. I mentioned deadlocks. Historically, it did have issues with deadlocking, but today, I'm pretty sure that it does meet my generic UPSERT definition for what it's worth. And just to emphasize, this is all about writing the statement once and forgetting about it. Leveraging the guarantee that you will get one or the other. Now I'm going to show you the syntax itself. What I've actually done here, what the feature actually does, is extends the insert statement, adding a new clause. So the first example is a standard generic UPSERT example, where we're inserting or updating 2 rows. The second is perhaps not an upsert at all. It's a similar feature that allows you to do nothing at all in the event of a would-be duplicate violation, simply go on without having inserted anything. And finally, we see a more involved example involving additional criteria, an additional qualification that is considered when going to update. So if it doesn't pass, then it isn't updated, obviously. Now, upsert differs a little bit. The update here, we see here, differs a little bit from a standard update in that with a standard update, you won't lock the row if the qualification doesn't pass, because, of course, otherwise you'd be locking virtually every row in the table, often. But with this, it does. So even if the qualification, in this case, the zip code, not equals 21201, even if that doesn't pass, you'll still lock the row, which is slightly different. Okay. So I'm highlighting here the excluded pseudo table. It's here. And that is a table that's there automatically. It's automatically visible in the context of the do update clause. And this allows you to reference rows proposed for insertion. So it's quite simply a way of referencing those only once. And if you have multiple rows you're inserting, this is absolutely essential, because you couldn't very well, contextually do that without having the excluded pseudo table. So this is something that is sort of feels like a. So obviously, if you have updates, you can have an update table from another table, which is a join in the context of an update. This kind of feels a bit like that. But you're updating from the excluded table. So you're updating table 1 from excluded, except that's implicit. So it feels exactly like you were doing a join-driven update, except it's a clause of the insert statement, if that makes sense. The alias does carry the effects of before insert triggers. So those effects will be evident from the values that you actually update to. So it's not necessarily the case if it's conceivable if you had an insert trigger, it would change those values, which is a sort of a minor note.
If it ends up being an update instead of an insert, then it will trigger the update triggers?
Yes, the triggers will run pretty much the least surprising way, which is that first thing you'll get is the before insert, and the update path is taken, then you'll do a before update. Point is, though, unlike you will have the effects of the insert even though you took the update path. If it's not an after trigger, but a before trigger. Okay, and here I'm highlighting what's called the inference specification, which is a way of being explicit about what you mean to take the alternative update path on. So here we see this did column is highlighted. And this is special and new. This is a way of making the intent of the statement explicit. It's a safety feature. So what we're doing here is figuring out a unique index, or potentially more than one, on which to take an update path on, or the update path on. This is something that is novel and unique to Postgres, or our version of this thing. And this is required for UPSERT, although it's optional for the do nothing variant, where you might reasonably not particularly care because you're doing nothing. If you're doing an update, though, were you to inadvertently take the wrong, if you didn't anticipate a violation in some other unique index, you might then spuriously update a row in a way you totally failed to anticipate. This is a problem still with the MySQL implementation that we've handily avoided here. I'm going to talk about the details of that, which are kind of interesting a little later. Yes? Sure.
What if what you want to do instead is to update a zip
A different table.
Yeah, sort of recording those that didn't make it.
Yeah, I think you can do something like that with merge and Oracle. What you could do is you could do an ignore, I suppose, but then, yeah, that would be tricky because I guess you can't do that because that would have to happen on the basis of something not happening, and you can't really trigger that so I guess the answer is you can't for now. Pretty sure that you can do that with some other things, so I guess that's something that someone could potentially work on. Yes.
Does this support returning?
It does. We'll get to that. Okay.
Question?
Yes.
What's on the last example,
Mm-hmm.
what's the difference between D and excluded?
The difference between dname and excluded.dname? Well, with Postgres, you're not actually supposed to qualify that this is on the target table. This is actually from the target itself. This, on the other hand, is from something that somewhat functions as if it was a distinct table containing the rows that you would have inserted, joined to the update like join thing.
Okay.
You know what I mean? So here, dname is what it is at the moment, and this is what we see here, anvil distribution. So it's kind of like there's two tables, even though one of the tables is sort of imaginary.
If I specify zip code in insert into those, then I can say excluded.zip code.
You could also do that. You couldn't put excluded in returning, but you probably wouldn't want to. But otherwise, yes, you can put it in the predicate. That's not restricted. Okay. Okay. So we specify what unique index to take the action on, or rather we have the system infer our intent from this specification. They can be in any order. This supports expression indexes, partial indexes, you name it. This also works with exclusion constraints, but they're only supported with the do-nothing variant because otherwise what would that even mean? Exclusion constraints, for those of you that don't know, are a mechanism they're typically used to solve something like the double booking problem. For example, in event management, we're currently in this room. Couldn't very well be the case that someone else was using this room at the same time. Now, if we had time slots, buckets of time, then we could probably use a unique constraint, and that would work. Exclusion constraints, though, can be used where we don't have buckets of time. We have this discrete and continuous type support. So we could have arbitrary intervals of time, and even if the arbitrary intervals overlap, then you get a violation. So it's much more flexible. Sometimes called a generalization of unique constraints. Now it would be kind of fuzzy if you were to upstart on that. It doesn't really make sense. But with do nothing, it certainly does. You can use those with do nothing. They work just fine. And these indexes that are, as I say, inferred, are called arbiter indexes, and they appear in explain output, as we'll see in a little while. Okay. So the question sometimes comes up, why not implement merge? Merge is in the SQL standard and appears to be similar to what I'm talking about. In fact, for a long time, people in the community believed it was, they were one and the same thing, but they're not, because merge is actually quite a kind of a different beast. It's sort of about reconciling two tables. It doesn't say anything about guarantees. In fact, the way it's described by vendors like Oracle, Microsoft, is that it basically will allow you to combine inserts and updates and deletes even, and to reconcile two tables. Maybe one of them is a values, so it's a kind of a temporary pseudo table thing, or maybe it's not. Maybe it's a actual table. This could be very useful for data warehousing, but it's entirely without any guarantees about outcome, which is really all I'm talking about and emphasizing, because I think that was much more compelling. So there is a place for merge, but it really isn't in competition with what I'm talking about. Maybe we'll do it in the future. To put it more formally, it's sort of it can have spurious dupe violations, except they're not really spurious because they never said that it would avoid that. And some people use merge naively, which is kind of a problem because they imagine that it's like what I'm talking about. It isn't. Now, is anyone familiar with this? Who's done this before? Yeah, I mean, people do this a lot. This is a way of doing UPSERT in a way that satisfies my definition of it in a laborious fashion involving subtransactions. This is actually from the PostgreSQL documentation. So this involves, this is actually a PGCL function with a, first of all, we're doing an update, we're checking if it affected any row, and if it did, then we're done. If it didn't, we have to insert in the event of a dupe violation there. That's actually where the subtransaction is. There's an infinite loop here. Now typically will be resolved very quickly, but in principle, it has to loop, has to keep trying until it gets one of those two outcomes. Now this is pretty ugly. There's some pretty obvious disadvantages with this. It's error prone too. It burns through transaction IDs, and those are, that's an expense best avoided in Postgres in general for various reasons I won't go into. And what if you have a dupe violation originating from not the target table, but another table affected by a trigger that you didn't even know was there? These things happen. And then you're anticipating that. You're anticipating a dupe violation in probably the primary key. And in fact, then you're taking the alternative path on some other dupe violation, some other table you didn't even anticipate. There are these sorts of hazards that are just sort of accidentally introduced. And this stuff does come up. So this is error prone and pretty terrible. It does work, but it's terrible. So when I was doing research on merge, which I wrote an awful lot about, I looked at how people were using merge, what problems they were having with it, and this is a Stack Overflow page, and this shows how people were complaining that merge, in this case with Oracle, would give you these, what they thought to be spurious duplicate violations. They weren't expecting this. They imagined that you get something like what I'm talking about. You didn't. And this was one popular answer, is you just do what I just showed you. You have a subtransaction here. This is PL/SQL. It's pretty much the same pattern, except there's just one merge as opposed to having an insert and an update separately. This just illustrates my point nicely, that it's really not that different from having an insert and an update within one statement, which is really significantly less useful than UPSERT. In summary, UPSERT is about guaranteeing a certain outcome, stringing together conventional DML statements, very useful in data warehousing potentially in particular. In data warehousing, when you're bulk loading a table, you maybe don't even have any index. And an index, a unique index, is really the only sensible way of, having a value locking mechanism. So you you have one choke point in a unique index, and maybe you don't even have one with merge because you're bulk loading a table. It's a data warehouse. Typically, those indexes will be created afterwards. They're not playing any sort of special games with visibility, anything like that. They're rather they're just doing, they're playing by the same rules as before, in essence. Now they could be, because it's just another join, my join is really very magical. It's not really a join at all, it just appears to be like one. Their join could potentially be, you could get a merge join plan in the plan, so that could be potentially an awful lot more efficient if you're not going through a unique index, if you have an awful lot of stuff that you need to process. Okay. Now, this is a MongoDB UPSERT bug. It's a recent issue. I didn't check if it has been fixed yet. I guess I should. But I'm not in the business of bashing MongoDB. It's not really my style, and I don't know much about it anyway. But I think this is an interesting example, and I saw similar issues in the past with MySQL. Because I naturally, when I was researching this stuff, I took a look at these kinds of historic issues. And this is, I believe, due to the Wired Tiger storage engine offering more granular locking. And I suppose as a consequence of that, they introduced problems with things like having dupe violations where they were not expected. More granular locking means you don't automatically have the benefit of any kind of way of serializing the upserting sessions. So you need to sort of make it so that you're inserting, and then if you have a disconnect between that and checking for a violation, then this sort of problem will tend to arise. So I'm not surprised that they had this regression. So it's kind of an interesting case of this problem coming up. I'm glad that I was so explicit about my goals in this project that this cannot happen. Identified that relatively early on, so that was good. Okay, so summary of what I said really. UPSERT is about guarantees. It's about you having those guarantees and you leveraging them to the hilt. No race conditions, but there are special games played, for example, with MVCC. There are special rules peculiar to UPSERT with regard to MVCC as a necessary consequence of what I'm talking about. So it is magical in that sense. Okay. Very happy with the syntax we came up with. I think it's pretty neat, pretty flexible. I don't think it's going to be something that could be standardized because these kind of concurrency control mechanisms are so complicated and peculiar to different systems. So I think, this sort of flexibility and safety we offer is pretty much a big competitive advantage for our version of this thing. Okay. So moving on, I'm going to talk about new use cases. So I guess everybody knows what UPSERT is now, if I didn't already. So at this point, I'll take any further questions. I guess it was kind of free form, but if anyone has any further questions on UPSERT, I guess not. Okay. I'm going to talk about data integration, which is an old-fashioned idea. So by discussing what is actually a fairly old-school problem, I'm sort of making the material more accessible than it might otherwise be. But this could very well apply to the gentleman from LinkedIn was talking about this morning. You've got a much more complicated data integration problem. I believe he worked for LinkedIn, but now he works with a Confluence, Kafka guy, basically. So you could have, it could equally well be that sort of thing I'm going to talk about, but it isn't, just for the sake of argument and simplicity. Okay. So we have all these diverse sources of data. We have little or no control for reasons that are not very interesting. They have a lot of autonomy. We can't very well just decree that they ought to, do things a certain way, because it just doesn't work like that in the real world. So, you have to clean the data. There could be different, although equivalent representations. There are different encodings, perhaps different ways that things like weights, volumes could be represented. For example, if you got products coming from Canada or something like that, maybe they're using metric units or some, that sort of thing. So that's sort of the problem area I'm talking about here. Integrating a bunch of diverse sources of data about, in my example, it's about products in a sort of supply chain system. So you have this sort of complex data landscape. Everything's messy, and that's just the reality. So in this environment, in general, idempotency is important. which is a property of UPSERT, typically. And that is that UPSERT statements may be executed multiple times without changing the result beyond the initial application. So you can do it multiple times. I mean, depending on how you structure the statement, but typically if it's a simple example, you can do it again and again. It doesn't matter how many times you actually ended up doing it. Kafka, I know, has loose guarantees about delivering things multiple times. So, it could very well be that this would be something you would leverage there. Okay. So we can't very well fence things to prevent these kind of anomalies from occurring, of course. It's just not practical today. Maybe a pure data warehouse could live with the downsides of merge, but that isn't our world, I dare say. Okay. So a little bit of this is my perspective in a slide. So you have all this complexity, and just be careful is a bad plan. It's not going to work. So the experience of the last 40 years suggests that we should have like a few good primitives that we can leverage a lot. And I think UPSERT is just such a primitive. We want to be able to address these problems in a simple way, so that just by doing things the easy way, they're also correct, to emphasize. Okay, and getting a bit more into the example. It's a simple one. It's a plausible case of what I've called an accidental distributed system. So it happens to be a distributed system that someone might write that doesn't know very much about distributed systems, but to some degree they're able to leverage UPSERT and its guarantees. Okay. So in this use case, there are disparate retail systems in the supply chain. Using all of these various terrible ad hoc text file formats, the retail outlets will sync with their various suppliers. This is a standard business information system type problem, really. So periodic syncing in these sort of ad hoc formats that are ill specified and not standardized at all. So you have a lot of legacy concerns in this example. And these files are downloaded in some kind of terrible way, like maybe it's something as primitive as FTP. This is an example of the tables that comprise the example. These tables are populated as part of this process of syncing, or updated even. So maybe it could be the case that some of the suppliers imagine they ought to be the exclusive supplier for a certain variety of products. They may not care about the distinction between things that they have exclusive control over. So they're not especially likely to want to facilitate any kind of standardization effort. This seems to be the reality in a lot of cases. Still though, product names maybe have to change at different times, things of that nature. And so we must allow updates to the products table here, and using these ad hoc text format files. I think that's pretty clear. You've got a products table, a suppliers table, and a supplier prices table. Okay, so here's what happens when you have a sync process. So this is kind of me getting to the, by way of this somewhat contrived example, getting to where the predicate could be usefully applied in the real world. So here we see a new product inserted or updated, and what's interesting about this is the predicate is discriminating against those products that have the supplier level record of the time it started from. If that's before our own, because you have to consider that there could be multiple suppliers supplying the same product. If that's different from our own, then we won't accept it. We'll consider that the existing newer one is authoritative, and then we won't update. Now, of course, we could just insert, we could update, or we could just lock the row and do nothing because it turns out that that version, the existing version we have, has more relevant or current information. The insert statements, this sort of thing can just happen without too much intellectual burden to developers who are not especially inclined to get these details right. Most people don't know the ins and outs of concurrency in database systems. It's often the case people aren't aware of the distinctions between the different isolation levels, and this is just something that you'll automatically get for free by just using doing it the easy way here. Okay, so with that, I'll take a beat. Okay, so I'm going to review more advanced capabilities of the feature. You've seen how UPSERT can selectively update a row, and a lot of detail work went into all of this, making sure that your favorite feature, whatever it is, works seamlessly. Particularly in the last year, I did an awful lot on making sure that everything fits well together, everything goes nicely together. It's kind of a principle of Postgres development that we will never throw something under the bus if it's an existing feature where you might reasonably expect it to work with a new feature. Then it's the new feature author's responsibility to make everything work well together. UPSERT, there was so many things it had to consider, but it did. So whatever your favorite feature happens to be, I mentioned exclusion constraints. There are a bunch of others. It's very, very thorough in just interacting well with other parts of your application. So you should be able to integrate it. No matter how exotic the features you're using, you should be able to integrate it with them very well, with maybe trivial exception. Okay. So I'm going a little bit back to in talking about more advanced features, I'm going a little back to the practical example. So here we see, suppose that we had a requirement for logical deletion of products. So over time, potentially, they could be logically deleted in the system. Still an ongoing requirement to have itemized sales records going back several years, even for logically deleted products. So you can't actually delete them. Typically, this is implemented in Postgres by using a partial unique index. So I have this is active column here. If it's true, then it's logically not deleted. If it's false, then it logically is deleted. So you could very well have, in each case, a partial unique index on, we'll say, barcode, even though that was in the original definition, in which case it would just work. The constraint would be enforced only among active products. And you'd probably still have an authoritative identifier like an SKU. Maybe it's a serial, something like that. But you wouldn't have to worry about reintroducing a product that was logically deleted that represents a different timeline of that product, if you know what I mean, or just that you didn't anticipate it happened, that kind of thing. This works very well already because we have these partial unique indexes, and something that is kind of neat. But what of UPSERT? Well, this will work very well with UPSERT. You'll get, and so what you're seeing here is this is another where clause. Now this is not the one you've already seen, because this is part of the unique index. And this is part of a unique index inference. So this is you potentially could have another where clause here. You just don't. So this is going to discriminate against, or rather not discriminate. It'll be less discriminatory. It won't discriminate against any unique indexes that are satisfied in every other way but happen to be partial, happen to say where is active.
Is active a keyword or a column in the products table?
It's a column in the products table, just like I said, indicating in the business domain, indicating that these products are they either are or are not logically deleted. Because we can't, like I said, we can't actually delete them. We still need that old data for historic sales records. So by having the partial unique indexes, you can sort of, if you didn't have partial unique indexes, then it would be quite bad that you might have dupe violations, but for deleted products, so what do you do then? That doesn't work, But just by having a partial unique index, that just sort of works. But it doesn't break UPSERT. UPSERT is going to handle that pretty well. You have to spell out that's what you want to do, and it just works. Again, everything goes down to it figuring out some available unique index to do this with. So, if we made the mistake of we require this for the update variant. So it's important that we are very forgiving of mistakes and yet totally unforgiving of things that will cause corruption. Okay, safety first. It's easy to use correctly and hard to use incorrectly. The semantics of the query depend on the presence of a constraint. This is kind of a novel thing. So we're saying a couple of things. We're saying, here's a novel thing about the presence or absence of a unique constraint and the presence or absence of a row changing the meaning or the path taken by a query. This is, to us anyway, a whole new idea. And if we're going to make you specify what you mean in terms of the unique index, we damn well better make sure that we don't have any sort of foot guns there. And so I'm going to get a bit more into the flexibility aspect of inference now. So this is an explain. Not everyone realizes that you can explain an insert, update, or delete, but indeed you can. You could very well have a join in such a statement. This is an example of what you see if you explain an insert on conflict do update. There's a little bit of novel stuff here highlighted. So what we're seeing here is the arbiter index. That is the index that is inferred, the index that we take the alternative path on in the event of a would-be dupe violation. Here it's UPSERT peak key. So you're actually going to see what the system, the optimizer, thought you meant when you wrote this. And that's what it is. Also seeing the conflict filter here, obviously a representation of this, showing you that additional information. And this is actually not an explain analyze, but if it was an explain analyze, you'd also see in practice how many rows were inserted or updated, which could be useful also. It's all there. I should also note that suppose you had a migration. For example, maybe you're adding a new index that's a partial index having had before a non-partial, more or less equivalent index, or maybe you're changing the ordering of columns in a unique index, or maybe the index is really bloated or something like that. There's many possibilities. You could very well do a create index concurrently. You can do a create unique index concurrently. That works fine. And then you'll have two indexes that are either identical or, for the purposes of this, at least equivalent. So what happens then? Well, there could be two arbiter indexes in principle. Typically, that's not going to be the case because they would tend to be redundant, but not always. And so here we see two. Because, of course, you're never going to anticipate this. It's too esoteric. It's too complicated. And so we sort of did a lot of work on figuring out what would bite people in practice, having introduced what is, as I said, pretty novel, pretty much a differentiator for the feature, that we make it safe, that we make it easy and safe. So we had to sort of think about those new problems that were a consequence of that whole idea, and that's what this is, really. So a bunch of edge cases like that we are handling for you. I won't say entirely seamlessly, but as good as it's going to get, I think. Okay, I'll talk a little bit more about inference. I mentioned expression indexes. So you could have an index on an expression which is also a unique index, as well as it being potentially also partial. It's immensely flexible. So indeed, that could be, rather than being a column, it could also have been an expression or a column and then an expression if it's a composite, and so on and so forth. That will work just fine. Extremely forgiving of ordering within the index definition. If it's ABC or BCA or anything else, it'll work just the same. Predicates in a partial index will work with anything that satisfies it. It need not be identical. It need only be a subset, provably a subset of the cataloged unique index definition. So it is possible, if you want to use an alternative. There's another spelling I didn't show you. I'm trying to discourage people from using it, even though for some reason they seem to gravitate towards it, which is, you could also say, instead of having the parentheses and having the columns, you could also do on conflict, on constraint, constraint name, which is just a way of explicitly spelling it out. Although it works with constraints, not indexes, and that distinction could be important there. Anyway, obviously that's not going to get you all this stuff. You're then kind of on your own. It's not going to be flexible. It's going to do simply what you say. Mostly, you shouldn't use that. Now, inference doesn't work with, as I mentioned before, you could use exclusion constraints for the do nothing variant. So you would have to use it for that, but you probably wouldn't even want to do that because you'd just be doing do nothing without qualifying what particular thing you cared about. So the fact that there's on conflict, on constraint, constraint name is really kind of an escape hatch sort of thing, not something that you ought to be using in the ordinary course of doing UPSERTs. So I'm writing documentation at the moment to tell people not to do that, because you want to have it just work when all these things happen that you couldn't possibly anticipate. And so just use inference and benefit from inference. Okay. I'm going to talk, yes. Okay. I'm going to talk now about other advanced features. Postgres foreign data wrapper supports the do nothing variant only. Most of you probably know Postgres foreign data wrapper is a foreign data wrapper that allows you to create an abstraction which is more or less like having on a foreign Postgres server, having those tables behave as if they were on your own local Postgres server. Pretty cool. So the do nothing variant does work with that, but not do update as a consequence of do update requiring an inference specification and there being no idea of a unique index or a constraint on a foreign table. So that's actually the reason why. So only do nothing works and only if you don't spell out exactly where you want, exactly what sort of violation you want to avoid. Or else the row-level security feature in 9.5 works very well. It's something that there's some amount of buzz about. This idea of having not only column-level privileges, but row-level privileges as well in the other sort of direction. So this was something that'll just work for the most part with not too much consideration given to UPSERT as a special case. It is mentioned in the RLS documentation, but pretty much it's just going to play nice with that. Updatable views also just work. There's a feature, I think it was a couple of releases ago, where you could update a view or insert into a view and have it redirected to the underlying table if it was possible to do so, and this will just work. So, in all cases, we want to sort of bring this intellectual burden right down, and that's really what I'm getting at here. Logical decoding plugins, they're going to see either an insert or an update. It's usually fine, depending on the exact requirements for the plugin. There's so many, you couldn't possibly anticipate them all. This new 9.5 subselect update list. So 9.5 has an unrelated feature where you can do, update table, set, and then you can have a list of columns, and then equals, and then a subselect, as opposed to you might otherwise have to have a bunch of subselects, which is ugly or something like that. So you can update a bunch of columns based on a corresponding other columns within a subselect. That'll just work here. And in general, so SQL merge has restrictions on subselects at different parts of the query, which are not obviously necessary. You kind of have a subquery in various different places. It's like you have this one join, and you can reference the target, and you can reference the thing you're joining against, but you can't just do subselects. But this doesn't have any of those restrictions at all. You can just do anything you can do with an update at all. You can have a subselect in the update list, in the predicate, anything like that. There's no structural restriction of that nature. Now, someone asked earlier about returning. Does that work? And yes, it does. The way it works now is just to tell people who don't know what returning is something you can put on the end of an insert, update, or delete, which will return in the fashion of a select those rows that were affected in each case. With insert, this will be those rows that were inserted. With update, updated. Showing, well, in case of insert, showing what you actually inserted, including any trigger effects, anything like that. In the case of an update, it'll show you the final version of the row. So what this does is it's kind of a hybrid. It'll show you those rows that were inserted, and it'll also show you the final updated run. So those will all be projected, as we say. So that's how that works. This implies that you could conceivably you could put, just as you could with any DML statement, you could put it in a with clause. You could so you have this with thing with Postgres, a CTE it's sometimes called, a temporary table that exists, if you will, exists only for the duration of the statement. And so Postgres is novel in that it allows you to put update or insert returning in those, but this is no different. This just works. You can sort of pipeline things using these CTEs potentially, so immense flexibility there. Partitioning, if you're using inheritance, that'll just do the right thing. You can, we really ought to have better partitioning in Postgres, but what we have right now will play nicely with this, or certainly no worse than inserts in general do with the existing system, such as it is. There's no, or very little, limitations in what you can do. And with that, I think I'm finished a little early. I will take further questions, of course, if anyone has them. No? Okay.
Which constraint you want to intercept violations for. If you get a violation on another constraint that you haven't specified, does that do nothing, or does it give you
Well, you can only really, granted you can infer multiple unique indexes at once, but those are assumed and restricted to things that are equivalent for UPSERT's purposes. So it ought not to matter that you get it in one first or the other first. What matters is that that it happened and that you're responding to it. You can't arbitrarily specify more than one index that is a fundamentally different business rule, a fundamentally different thing being constrained, because if that happened, then what would you do in each case? What if they were both violated? And it gets very scary very quickly. So yeah, people actually often ask me that question. Why not have support for two alternative paths? And then I always say, well, what happens if you have to take both of them? So there's like sort of fundamental laws of physics, sort of reasons why everything is in terms of an insert, and then if there's a dupe violation, an update. Having multiple constraints that are not essentially the same would have a lot of problems with, what do you do in each case? So that's sort of the way it works. Does that make sense?
Well, yeah, I understand, but my question is, in the case where I expect to anticipate this possible violation,
Yep.
and if it happens, do this.
Mm-hmm.
Some other violation happens.
Well,
Will you get
no. No, you're on your own then. It's not designed. I mean, hopefully, at that point, it doesn't so much, it's not really something you can do anything about, because at that point.
No, I'm just asking.
Sure.
Will it fail?
Oh, yes, yeah. And of course, the whole point of the inference specification is that it will fail if it's not the thing that you inferred, that you limit your consideration of expected or potential handled dupe violations to just that business constraint or rule, which could, in edge cases, be more than one unique index, but probably not. So yeah, it's sort of impossible to make it be super fancy, but then I tend to think that the solution there is just have two inserts, and that will work just as well. And that's sort of the way it is, So yeah, you're not actually going to physically check for a violation in the second unique index, having gotten one in the first, but it ought to be there, or if it isn't, it doesn't matter. If you know what I mean. Well, actually, it definitely will be there, so we don't bother checking, but because those have to be equivalent in all ways that matter to UPSERT, if you know what I mean. Those have to be not necessarily identical, but identical for our purposes. So, that's just how it works. Any other questions? No? Okay, thanks.